Hello, guys. Good day to our lecturer, Mr. Salman, and my fellow classmates. This video is about the topic simulation from IR 4.0. This video is presented by me, myself, Dharani, and my friend Sri Bhuneswari. First of all, what is Industry 4.0? Industry 4.0 refers to a new phase in the industrial revolution that focuses heavily on interconnectivity, automation, machine learning, and real time data. Industry 4.0, which encompasses IoT and smart manufacturing, marries physical production and operation with smart digital technology, machine learning, and big data to create a more holistic and better connected ecosystem for companies that focuses on manufacturing supply chain management. There are 9 different topics given to us in the IR 4.0. The topic we choose is simulation. Simulation refers to imitating the real world system or process over time. Such imitations enable experts to closely evaluate real world processes or system in controlled environment. Simulation plays a critical role in diverse fields and industries, enabling us to model complex systems, test hypotheses, and make informed decisions. There are many simulation software options available for companies to use in their Industry 4.0 initiative. This software solution can simulate various aspects of production, such as material handling, assembly lines, and logistics. Some examples of Industry 4.0 simulation software includes Simio, AnyLogic, and FlexSim. Simio, for example, is a simulation software that can model and simulate complex systems using a combination of discrete event, agent-based, and continuous methods. AnyLogic, on the other hand, is a simulation platform that can model and simulate different types of systems, including manufacturing, supply chain, and transportation. FlexSim is a simulation software that specializes in modeling and simulating complex manufacturing and logistics systems. By using simulation software, companies can optimize their Industry 4.0 initiative and minimize risk associated with their implementation of new technologies. They can also make more informed decisions about their production processes, reduce costs, and improve overall productivity. Simulation is a powerful tool for decision making as it enables decision makers to test different scenarios and evaluate the impact of changes to system without having to make expensive or time consuming changes to the real world system. Simulation is also a valuable tool for research as it enables researchers to test theories and hypotheses in a controlled environment. Simulation applications to showcase the diverse application of simulation in different domains. First of all, simulation in manufacturing refers to the use of computer-based models to simulate manufacturing process and systems. This simulation can be used to model a variety of different scenarios such as production line setups, product designs, and supply chain management. Simulation in manufacturing can help companies to optimize their production processes by allowing them to test different scenarios without having to make a costly physical changes to their production lines. This can lead to improved efficiency, reduced cost, and higher quality products. Application simulation in military is training soldiers in different scenarios, testing new equipment and tactics. Operation simulation training refers to simulating the operation process of weapons and equipment by means of simulation technology, which save time and effort, can reduce the technical wear of weapons and equipment, and is widely used in various types of military equipment training. Maintenance simulation training refers to simulating the whole process of maintenance by means of simulation technology. There are 3 stages, which is fault presentation, fault analysis, and fault elimination. Virtual maintenance can solve the problems such as difficulty in fault reappearance and unsuitable for practical training. Furthermore, simulation applications in healthcare, which is complex medical procedures, training medical professionals, and predicting disease outbreaks. Medical simulation has been found to enhance clinical competence at the undergraduate and postgraduate levels. It has also been found to have many advantages that can improve patient safety and reduce healthcare costs through the improvement of the medical providers' competencies. Simulation in transportation is simulating traffic flow, testing new transportation design, such as mathematically modeling of transportation system, such as routes, roundabouts, downtown grid system through the application of computer software to help plan, design and operate transportation system. Simulation of transportation systems started over 40 years ago and is an important area of discipline in traffic engineering and transportation planning today. Various national and local transportation agencies. Simulation in transportation is important because it can study models too complicated for analytical or numerical treatment, can be used for experimental studies, can study detailed relations that might be lost in analytical or numerical treatment, and can produce attractive visual demonstrations of present and future scenarios. To understand simulation, it is important to understand the concept of system state, which is a set of variables that contains enough information to describe the evolution of the system over time. System state can be either discrete or continuous. Traffic simulation models are classified according to discrete and continuous time, state, and space. Simulation in transportation can be done using a variety of software tools such as traffic simulation software, transit simulation software, and logistics simulation software. These tools use mathematical models and algorithms to simulate transportation system and processes and provide insight into potential improvements. Last but not least, simulation application in finance. Modeling financial markets, predicting economic trends, and forecasting investment outcomes. In finance, simulation analysis is a model that applied to analyze large projects and determine how target variables are affected based on changes in input variables. The model uses simulations to predict how the outcome of a decision would vary if they tweak a set of input variables in a given range. Challenges in simulation.
Assumption and limitations. To identify the assumption and limitation occurs with simulations. Assumption must be made about the system being simulated. Assumptions may not always reflect the real world accurately. Assumption can lead to inaccurate results. Moreover, the model accurately represents the real system. The simulation model should closely match the real system in terms of its behavior, characteristics, and dynamics. If the model does not accurately represent the system, then the simulation results may be invalid. The input data is accurate. The accuracy of the simulation result depends on the accuracy of the input data. If the input data is incorrect or incomplete, then the simulation results may not be reliable. Other than that, depend on input data, the accuracy of simulation results is highly dependent on the accuracy of the input data. If the input data is incomplete, outdated, or inaccurate, then the simulation result may not be reliable. Limitations may arise from data collection or analysis. Limitation can affect the accuracy and reliability of simulations. Limitations can be due to power or resources. High cost and time requirement. Developing and running a simulation model can be expensive and time consuming. The accuracy and usefulness of the simulation may not justify the cost and time required to develop it. Data collection and validation. Challenges in simulation. Lack of data availability, difficulty in getting relevant data for simulation. The lack of Data availability for simulation can be a significant challenge for researchers and organizations looking to use simulation technique for various purposes. Without enough data, it may not be possible to accurately model and simulate real-world systems or processes. This can lead to unreliable or inaccurate results, which can ultimately undermine the effectiveness of simulation as a tool. One way to address this challenge is to collect more data through experimentation or observation. This can involve designing experiments that generate data that can be used to do, validate, and refine simulation models. Alternatively, organizations may need to invest in data collection technologies or partnership with other organizations to gain access to the data they need. Second challenges in simulation is data quality. Incomplete, inaccurate, or outdated data can lead to incorrect simulation outcomes. Data quality is essential in simulation because inaccurate or incomplete data can result in simulation models that produce errors outputs. Poor data quality can result from a range of factors, including measurement error, data bias, data incompleteness, and data inconsistency. Third challenges in simulation is data variety. Data variety is data from different sources with varying formats can make it difficult to integrate into the simulation. Data variety in simulation refers to the use of derived and representative data in the simulation process. In simulation, data is used to model and simulate real-world systems, and the accuracy and reliability of the simulation depend on the quality of the data used. Last challenges in simulation is data privacy and security. Confidentiality of sensitive data and potential security breaches are concerned in data collection and management for simulation. Secure data transfer protocols. Using secure data transfer protocols such as HTTPS can help protect data during transit. To ensure data privacy and security in simulations, several measures can be taken, including data encryption. Encryption data in transit and at rest can help prevent unauthorized access to sensitive information. Regular data backups. Regular data backups can help protect against data loss due to hardware failure, natural disaster, or cyber attacks. The future of simulation is likely to be characterized by continued advancement in technology and increased use of simulation across a wide range of fields and applications. Here are a few trends and developments that may shape the future of simulation. Increased use of AI and machine learning. As AI and machine learning technologies continue to advance, they are likely to play an increasing important role in simulation. For example, algorithms could be used to optimize simulations or to automatically generate simulation based on input data. More sophisticated models as computer processing power and data storage capabilities increase, simulation models are likely to become more complex and realistic, allowing for more accurate prediction and insight. Increased use of virtual and augmented reality. Virtual and augmented reality technologies are already being used in some simulation applications, and their use is likely to become more widespread in the future. This could include using virtual environments to train pilots, surgeons, or other professionals, or using augmented reality to overlay information into real-world environments. Greater integration with real-time data. Simulation is likely to become increasing integrate with real-time data from sensor and other sources. This could allow for more accurate and dynamic simulations that respond to real-world events in real time. Expanded applications. As simulation technology continue to advance, it is likely to be used in a wider range of applications across industry, including healthcare, transportation, finance, and more. Overall, the future of simulation is likely to be shaped by ongoing technological advancement and increasing use across a range of applications and industry. As simulation become more accurate and integrate with real-time data, they are likely to become even more valuable tools for decision making, training, and research. Summary of simulation process. Provides an overview of the simulation process, including its stage and methods for students studying simulation theory or computer science.